here to witness the inaugural function of the 22nd Control Instrumentation Systems Conference, CISCON 2025. CISCON 2025 is technically sponsored by IEEE Bangalore section. CISCON 2025 shall provide a forum for researchers, industrial fraternities and academia to deliberate and exchange problems and ideas on latest trends in instrumentation, control and systems engineering. Today, on this auspicious day, we have with us eminent personalities gracing the occasion. We have with us Dr. Ravi Kumar L., Group Director, Mission Simulation Group, CDA, UR Rao Satellite Center, ISRO, Bengaluru, as the chief guest. Dr. Shankar Venugopal, Vice President, Mahindra & Mahindra, Chennai, as the guest of honor. And Commander Dr. Anil Rana, Director, Manipal Institute of Technology, as the President of the function. I now request Dr. S. Meenakshi Sundaram, Professor and Head Department of Instrumentation and Control Engineering, MIT Manipal, and Dr. Chinmay Rajhans, the convener of CISCON 2025, to escort the dignitaries to the dais. Thank you, sirs. A day without prayer is a day without blessing, and life without prayer is a life without power. I now call upon Dr. Bhagya R. Nawada, Associate Professor, Department of Instrumentation and Control Engineering, to render the invocation. I request the audience to be seated.
ಮಹಾಗಣಪತಿಯ ಮನದಲ್ಲಿ ನೆನೆಯುವೆ ದೇವತಾ ವಿಮುನಿ ವಂದಿತನ ಮಹಾಗಣಪತಿಯ ಮನದಲ್ಲಿ ನೆನೆಯುವೆ ದೇವತಾ ವಿಮುನಿ ವಂದಿತನ ಗುರುಗಳಿಗೊಡೆಯನ ಮಹಾದೇವಸುತ ಬಹುರವಿ ತೇಜನ ನಮಿಸುವೆನಾ ಗುರುಗಳಿಗೊಡೆಯನ ಮಹಾದೇವಸುತ ಬಹುರವಿ ತೇಜನ ನಮಿಸುವೆನಾ ಮಹಾಗಣಪತಿಯ ಮನದಲ್ಲಿ ನೆನೆಯುವೆ ದೇವತಾದಿ ಮುನಿ ವಂದಿತನ ಮಹಾಕಾವ್ಯ ನರ್ತನ ಮೆಚ್ಚಿದ ಮೂಷಿಕ ವಾಹನ ಮೋದಕ ಪ್ರಿಯನ ಬೇಡುವೆ ಕರುಣಿಸುವಿದ್ಯೆ ಬುದ್ಧಿಯ ಏಕದಂತ ಕರುಣಾಮಯನ ಬೇಡುವೆ ಕರುಣಿಸುವಿದ್ಯೆ ಬುದ್ಧಿಯ ಏಕದಂತ ಕರುಣಾಮಯನ ಮಹಾಗಣಪತಿಯ ಮನದಲ್ಲಿ ನೆನೆಯುವೆ ದೇವತಾದಿ ಮುನಿ ವಂದಿತನ.
Thank you, madam, for the melodious entering. May I now request Dr. S. Meenakshi Sundaram, Professor and Head Department of Instrumentation and Control Engineering, to welcome the gathering.
A very good morning. It gives me an immense joy and pride to stand before you today and extend a warm welcome to each one of you to the inaugural ceremony of the 22nd edition of CISCON 2025, the annual flagship event of the Department of Instrumentation and Control Engineering, MIT Manipal. CISCON actually holds a deep emotional significance for all of us in the department. It is a tradition we cherish, something that has grown with us over the years. I feel privileged to share that only 3 of us in the department have been part of this journey since its inception and continue to be so in this 22nd edition. So, CISCON was first envisioned on 2004 by our former HOD, Dr. V.I. George, as a tribute to the first graduating batch of our department. What began as a one-time effort has evolved into a prestigious annual conference, and I am proud to say that we have conducted it without missing a single year for over 2 decades. While conferences are basically platform for knowledge exchange and networking, CISCON stands apart in many ways. Let me share a few. First, CISCON has been an annual exercise in terms of building and leadership development. We created a system where each year's convener is supported by 2 co-conveners, one of them whom transitions into a convener's role in the following year. This model has not only nurtured leadership but has also fostered collaboration and continuity among our team. Second, CISCON taught us resilience. I still vividly recall the year 2004 when we are running between Patla to Udupi to get the conference proceedings printed, covers designed and binding completed, all to ensure we could distribute hard copies to the participants on time. The motivation was so strong that even saving 2 paisa per page was a strategic decision. These challenges gave us confidence and resourcefulness that continue to guide us. CISCON is also a time of celebration and togetherness, a moment when our department feels like a family. It has given us a reason together, reconnect and share joy everyone, fostering a sense of belongingness that has strengthened our department culture. Now a brief word about the department itself. The Department of Instrumentation Control Engineering was established in the year of 2001, with the first batch graduating in 2004, initially offering a BTech in Instrumentation Control Engineering with an intake of 30. We later expanded to 60. In 2018, the program was restructured as BTech in Electronics and Instrumentation Engineering with an intake of 120. In 2022, we introduced BTech in Cyber-Physical Systems, beginning with 60 seats and then expanded to 120 in the year of 2025, while the AE, Electronics and Instrumentation, intake has been revised to 60. We also have postgraduate programs like MTech in Control System. It was from 2005 to 2021, later restructured to MTech in Embedded Control and Automation from 2022. Other PG programs have included MTech in Aerospace Engineering, MTech in IoT, and we have a new program floated this year as MTech in Immersive Technology. The department also offers a PhD program in the areas such as instrumentation, control systems, biomedical applications, and allied domains. With that introduction about the CISCON and our department, it is my honor to welcome our chief guest, Dr. Ravi Kumar, the Group Director of Mission Simulation Group, URSC, Bangalore. Thank you, sir, for your presence here, accepting our invitation and gracing this event. I also extend a warm welcome to our guest of honor, Dr. Shankar Venugopal, Vice President, Mahindra & Mahindra, for his gracious presence and support to this event. Welcome you, sir. I am delighted to welcome our own beloved director, Commander Dr. Anil Rana, whose leadership continues to be an inspiration for all of us. Welcome you, sir. My heartfelt welcome goes to all the associate directors, deans, head of the departments, faculty members, students, and finally the participants of this program, both those are present here as well as joining with us in virtual mode. We are confident that CISCON 2025 will meet your expectations and provide an enriching platform for interaction, learning and collaboration over the next 2 days. Thank you once again and welcome to CISCON 2025.
Thank you, sir. On behalf of the faculty and staff of IC department, I extend a warm welcome to Dr. S. Meenakshi Sundaram, head of the department, and Dr. Chinmay Rajhans, co-convener of CISCON 2025. CISCON is an annual conference organized by the Department of Instrumentation and Control Engineering, MIT Manipal. CISCON 2025 is the 22nd in the series. I request Dr. Chinmay Rajhans, the convener of CISCON 2025, to give an overview of the conference.
Good morning, everyone. Most of the things HOD sir has already told. Welcome to all the dignitaries from various places, from various big places they have come here. Some dignitaries are sitting in front of us also. Welcome to all the students, participants, authors. Some reviewers may be also here sitting, and my department colleagues and other department colleagues of MIT and MAHE. Welcome all. Let me very briefly give you this overview. As mentioned, CISCON was started in 2004. It's been an annual conference, always growing year after year and achieving some new things. Initially, earlier years, we had proceedings with Springer, but since last year, we went with IEEE, and this year also we are with IEEE Bangalore. This is the 22nd edition. This particular edition has 3 keynote talks. 2 will be today itself, immediately after this inauguration. The 3rd will be tomorrow morning. This particular edition, we had exactly 1002 papers. We got the approval in the February month. From February and right now we are in August. So you can imagine within 6 months we have a conference with 1000 paper submissions. Some papers had 1 to 5 number of authors. So total number of authors 7 across India and some across world also. We initially checked each and every paper one by one for plagiarism. Approximately 350 papers were found to have plagiarism above 20%. IEEE allows above 30%, below 30%, but we thought we should have a quality, so we selected about 20%. All the papers were above 20%. We gave them second chance to reduce the plagiarism and submit it again. So these people submitted again. Exactly 650 papers which were below 20% plagiarism were sent for review. We had 480 reviewers across India and world, 480 reviewers which helped us in reviewing. Every paper got 3 or more reviews, with some papers getting up to 8 reviews, right? And finally, out of this total number, we just have 183 which are finally accepted and presenting. So the papers are divided into 6 tracks. Tracks are already known. Let me just briefly. First track is control instrumentation automation. The second track is communication and signal processing. Third track is cyber physical systems. The fourth track is interdisciplinary system design, because interdisciplinary research is important. The fifth track is data science and engineering. And the last track, which first time it was introduced in this particular edition, was sustainability technologies, because it's important to connect this work, what a technology you are developing with society, and what is the impact on environment, etc. So we had track on sustainability. We got papers in all the 5 tracks, less or more. These papers, 183 papers, will be presented in 2 days in 5 different sessions. Each session having these 6 tracks, each track having 6 to 7 papers, right? And we also have best paper award for every track. Usually the result will be decided by session chair and co-chair. We have total 60 chairs and coaches total in number, out of which approximately 45 are from outside Mahe. Okay, outside Mahe, 45 approximately. Right? And we really thank all of them for being there and for their support. I'm not sure if this will come anywhere, but there's also cultural evening in the evening today itself for all the offline participants. You are all invited there for the cultural evening at Fortune in Valley View. The vote of thanks will be there later, formal vote of thanks. I'd like to thank everyone who is involved in this conference directly or indirectly. It's been many people put together. It includes everyone. It includes right from authors, reviewers, Mahe, MIT, dignitaries, officials, various vendors who supported us, audiovisual team, and the many to thank. The formal vote of thanks will cover everyone. Thank you everyone.
Thank you, sir. Lighting the lamp is an art, a ritual, a discipline. May I now invite the esteemed dignitaries on the dais to light the lamp and formally inaugurate CISCON 2025. Thank you, sir. Ladies and gentlemen, today we have the privilege of having with us an eminent scientist and a passionate researcher, Dr. Ravi Kumar L., Group Director, Mission Simulation Group, CDA, UR Rao Satellite Center, ISRO, Bengaluru. May I now request Dr. Srisha C., Professor in the Department of INCE, to introduce the chief guest to the gathering.
Good morning, everybody. I am standing here with a mixed feelings because the CISCON 25 is initiated by me and conducted by Dr. Meenakshi Sundaram. I am very much privileged to introduce the chief guest of today's inaugural function, Dr. Ravi Kumar L. Dr. Ravi Kumar L. is graduated in Electronics and Communication Engineering, MTech in Instrumentation Engineering, and he completed his PhD in Aerospace Engineering from IISc Bengaluru. He has joined the Control Systems Group, UR Rao Satellite Center, ISRO, during 1997, and he has been involved with the design and development of attitude and orbit control system for spacecraft and autonomous LEB sequencer design for Mars Orbiter mission. He has been Deputy Project Director, SpaceX, NAVIC, INSAT 4C, 4CR, and GSAT 7. The major contribution includes development robotics based Rendezvous Simulation Laboratory for SpaceX testing. Currently, he is Group Director for Mission Simulation Group, CDA URSC. His contribution includes development of hardware and software for satellite dynamics, attitude control, interplanetary missions for hardware-in-loop simulations. In addition, he has been working in space, robotics, cooperative control, formation control, optimal control, computer vision, AI and ML for future space application. His He is awarded PhD on Advanced Constraint Optimization for Space Rendezvous and Docking. He has published more than 35 technical papers in national and international journals. So with this, I'll be presenting to you today's chief guest, Dr. Ravi Kumar L, and request him to deliver the inaugural remarks.
Thank you, Professor Sisha. Good morning to all. It's my privilege and I feel very happy and proud to be here in front of you people, because this control system is close to my heart actually. I have been working in this control system for the last 28 years on the spacecrafts, launch vehicles, as well as the space robotics. Now that trends are changing actually, if you see this one, that my beginning of the career and now today, all the engineering fields are like a merging kind actually it is happening. So you can see that one, that earlier some classical control was there, now it has become like it is gone to the advanced controls actually. In this advanced controls, AI based controls all. So trends are changing, our fields are merging. So it is very glad to see this kind of gathering and motivate that young students, researchers and professors continue effort to the national interest of that all industrial engineering applications. That instrumentation is a major activity we consider in that, even in the spacecraft applications also, because that actually systems will not work as you think. It is having the inherent issues like disturbances, noisy nature, stochastics, signals. So conditioning of the signals is very important aspect, and control of those things also very important. So now that actually speaking that this area is going to be that one of the prominent area, because that why I am insisting on this one is totally future is going to be that AI based automations will be going to come into. Suppose even for that smart sensors are coming, and that AI based applications in that anomaly detections in the sensors in itself inside embedded with the intelligence. So intelligence sensors are going to play role, where that controls and instrumentation is going to be the major role. And along with that, all that system engineering is going to be the major role for this future applications. So any field if you take that, this is going to be the very important aspect. So even though AI and ML applications are there, but core engineering is very important. Core engineering in the sense that fundamentals of control systems, fundamentals of the signals and signal systems and the instrumentation is very important to evolve that future industrial applications and robotics applications. I think with this, I hope that it will be motivating to us for next couple of days in this area, because that I have seen that the curriculum and also that what are the progress is happening from the last couple of years. I'll also extend my support in case if anybody requires any help from that any activity related to the spacecraft applications and building up that nano satellites, CubeSat kind of things. So I will forward to that actually help in your designs and applications, whichever it is applicable for industrial applications also. My contribution will be there. With this, I hope that next 2 days sessions will be fruitful for your future applications. It will emerge like something like take away from this will be you will be fixing your PhD topics or fixing your future goals with these conferences, because that outgoing students, it will help in that their future decisions also. With this, I hope it will motivate you people better way to progress. Thank you.
Thank you, sir, for highlighting the importance of core engineering fields, instrumentation and control systems. We look forward to hear you more in the keynote address. May I now request Commander Dr. Anil Rana, Director MIT, to present a memento to our Chief Guest, Dr. Ravi Kumar, as a token of our gratitude. Thank you, sir. Ladies and gentlemen, today we have with us an expert in technology scouting and R&D management, Dr. Shankar Venugopal, Vice President at Mahindra & Mahindra, Chennai. May I now request Dr. I. Tirunavukarasu, Professor in the Department of INCE, to introduce the guest of honor to the gathering.
Good morning. Dr. Shankar Venugopal is a Vice President at Mahindra & Mahindra. He leads the technology, innovation and intellectual property portfolio for Mahindra's automotive and farm business. He is the Dean of the Mahindra Technical Academy. Dr. Shankar has led technology innovation at GE, Dow, Honeywell and Cummins prior to joining Mahindra. He holds a PhD in Material Science from Indian Institute of Science, Bangalore and a management degree from Indian Institute of Management, Bangalore. He is a prolific inventor with 30 international and Indian granted patents. He won IASC Best Thesis Award, GE's Edition Inventor Medal and Prolific Inventor Award, World Intellectual Property Forum. He was a member of the B20 Task Force for Driving Technology, Innovation and R&D for Business Growth. With this introduction, I present you before Dr. Shankar Venugopal. Over to you.
Good morning. When I came to know about this event, it was somebody who spoke to me over phone, and because of the poor connectivity, I heard it as ISCON. So I was wondering, what will I do? What should I speak on? And then luckily got clarified and I understood what CISCON is about, and it's really nice that I'm here to be here. And I'm from the automotive industry. I'm based out of the Mahindra Research Valley, which is in Chennai. There are about 4,000 plus engineers out there building new products, and the most recent being the born electric vehicles, the B6 and the 9E that you might have seen. Has it come to Manipal? Have you seen it on Manipal roads? Okay, great. Nice to see that. So a lot of it is what we work on. We work on next-gen technologies. So if I had been attending this conference, say 5 years back, the car, the SUV, was predominantly a mechanical system. So there wouldn't be much that I could have spoken on electronics and controls. But today, the car is shifted from the ICE to electric. So there has been a steady increase in the amount of electronics that goes into it. The engine and many of the mechanical components have been replaced by the battery, the motor, the electronic control systems. So the EV shift has already happened. It's here and now. And so we need a new breed of engineers called mobility engineers to work for the automotive industry across the globe. These mobility engineers need to be good in mechanical engineering, electrical and electronics, and computer science. All these branches have become equally important, and so we want you, when you are here in this great campus, to not limit yourself to just one domain, but really try to pick up as many skills as possible across adjacent domains. That's what would help us to build world-class vehicles here in India and take it to other parts of the globe. What's going to happen in the automotive domain next is even more interesting. We call them as software-defined vehicles, where software will be the front face and products will be differentiated based on what the algorithms and the software can do. That's where we leverage the power of AI to really do wonders for us. So India has a great opportunity to be a leader in this emerging technology space and build products that are globally relevant. And you are all here at this right time to prepare yourself to enter such an exciting industry. It's a best of best times. Finally, all this will be possible only when the industry and academia come together and work. Industry can't do this alone because we need to do a lot of very deep focused, intense research to build technologies and put them in these products. So that's the reason why I'm here today, so that I can meet you all, both the faculties, the students, understand your research interests, the kind of problems you work on, and see how we can all collaborate on this together. So with this, I wish CISCON all the very best, and I look forward to a lot of learning from you all here today. Thank you so much. Thanks.
Thank you, sir, for briefing us about the opportunities in automotive industry. We look forward to your keynote address soon after the inaugural function. May I now request Professor S. Meenakshi Sundaram, HOD ICE MIT, to present a memento to our guest of honor, Dr. Shankar Venugopal, as a token of our gratitude. Thank you, sir. Ladies and gentlemen, today we have with us a dynamic personality as the president of the inaugural ceremony, Commander Dr. Anil Rana, Director, Manipal Institute of Technology, Manipal. May I now request Professor Sureka Kamath, Department of INCE, to introduce Commander Dr. Anil Rana to the gathering.
Good morning, one and all. It's my privilege to introduce President of today's function, our Director, Dr. Anil Rana, to the gathering. Dr. Rana has served as a Commander in the Engineering branch of the Indian Navy in various roles and has over 30 years of experience in the industry and academia. He has a PhD in Reliability Engineering from IIT Bombay and MTech from IIT Delhi. Before his naval service, he served as the Associate Dean Research and Professor of Mechanical Engineering in Fiji National University in Fiji Islands for 5 years, followed by Dean Academics in BSDU, Jaipur, before taking over as a Vice Chancellor of Oriental University, Indore in February 2021. His research interests include reliability engineering, maintenance engineering management, stochastic Petri nets, machine learning, fuzzy and neuro-fuzzy applications in the field of maintenance engineering. He has many publications in national and international journals as well as conference. I would like to invite Dr. Anil Rana and I request him to address the gathering.
Dr. Ravi Kumar, the chief guest present here, the guest of honor, Dr. Shankar. Thank you so much. This is your first visit to Manipal. There's a lot to see in Manipal. I am told Dr. Ravi is going to leave today. That's very unfortunate. Maybe next time you come here for a longer duration so that we can take you around. You need at least 2 to 3 days to look around Mahi and MIT facilities alone. HOD, Dr. Meenakshi, and the convener, Chinmay. Distinguished guests present physically and online, my MIT colleagues and my dear students, gives me great pleasure to be here for the 22nd CISCON conference. And I'd like to compliment the department, Instrumentation Control Engineering, for holding this particular conference, which is very, very important. I'll tell you why. But before I go there, I would just like to talk about what Dr. Shankar had mentioned. We also had our own snafu here yesterday. A late night after finishing the research conclave, which ran for 2 days, and it was quite engaging, I would say. So Dr. Meenakshi came to my cabin and he was trying to remind me that we have CISCON today in the morning, 9:30. And I asked him to just run me through the names of the chief guest and guest of honor. So he said, Dr. Ravi is coming. I said, fine, good. And he said, Dr. Shankar Mahadevan is also coming. And I said, wow. Yeah. But we are very pleased to have Dr. Shankar very far with us and not Shankar Mahadevan. Otherwise, I'm sure the student community, Rebels especially team, would have been very happy to have Shankar Mahadevan also. Anyway, going further, what both of them mentioned or underscored a point which I have been making in many of the conferences, that engineering disciplines or the technology, so to speak, is converging. So the line which earlier demarcated different disciplines is blurring. So even when I talk to my civil engineers, they're talking about AI/ML, they're talking about IoT, they're talking about sensor technology, because now it is all getting integrated together. You look at a product in the market, and there are so many products displayed in the research conclave, and you can't say this is a product of mechanical engineering discipline. You cannot say that, because it's all coming together. So therefore now there is a need that especially the students and also the faculty members, people like us, to know more and more about other disciplines. And that is becoming very, very important. Gone are the days when I was in the service and it was very easy for the mechanical engineers to pin the blame on the electrical engineers for something going wrong. Even a simple thing like a centrifugal pump, and something goes wrong and the mechanical guys will say, nothing wrong with my pump, it's the motor problem. And the electrical guys would say, nothing wrong with the motor, it's the pump problem. And there used to be generally a problem, and then the officers had to sort it out. But now the days have gone, now the entire system is under one command, and the engineers are responsible for everything. I am very happy to announce here, I was talking to Dr. Ravi. He has also offered his help of his center. We are coming up with a satellite technology center, and for the students, I think it's very important to know. Very soon we'll be manufacturing satellites here, and that center is going to come somewhere close to the architecture block, if you have ever been on the other side. And in addition to that, we will also be coming out with a ground station for processing of data. And this entire exercise is happening in collaboration with a very successful startup now running a full-fledged business in India called Dhruva Space Tech. And therefore it is very important for us to know more about satellites. And when you talk about satellites, the important part, one of the main projects is actually with this department working on the control system of a particular project. So therefore this department will surely be totally immersed in that project, and all the students will definitely benefit. All it takes is you to be curious and ask your faculty members as to what's going on, and try to find out, participate in the activity that is happening. I'm sure you're going to learn a lot. Coming to the next step of defense technology, the country today is looking forward to the engineers, especially the young ones, to participate in the national priority area projects. So whether it is quantum technology, whether it is satellite technology or the defense technology, the entire field is now getting open to private players. And therefore there is a requirement of large number of engineers and scientists to come together and participate in this national drive, so to speak, so that we become self-reliant. I'm sure you are reading the newspapers, there's something very crazy going on in the world. One day you are the best friends of somebody, and next day they're enticing your enemy. So therefore, I think it's a big requirement today that you be self-reliant, don't depend on anybody. I think ISRO long ago had showed us a way, and they've done some amazing things. Same with DRDO. And every such technology or a product that you see, from Akash missiles to RPSLVs, there's a big role to be played by the control system. That becomes the heart of the entire product, because when you are having a supersonic missile coming towards you, there's hardly any time to react and then take that down. It becomes very, very important for this particular technology to progress, and we need many engineers and scientists to come forward, do research, and make your products superior to those than those with the enemy. So I'll just like to stop here. I'd like to wish this particular conference great success. 2 days of engagement, I'm sure, is going to be beneficial for everybody, faculty members, researchers, and the students. Please also network with the experts who are here. They're generally not seen. There's this. They are just visiting us for the first time. But I'm sure the networking will help you in your future. Thank you. Jai Hind.
Thank you, sir, for your words of encouragement and continued support in all our endeavors. A thankful heart is not only the greatest of all virtues, but also the parent of all virtues. I now request Dr. Himanshu Gupta, co-convener of CISCON 2025, to propose the vote of thanks.
Thank you, sir. Respected dignitaries, esteemed guests, and dear participants, it is both an honor and privilege to stand before you to deliver the vote of thanks on behalf of the CISCON 2025 Organizing Committee. No event of this stature comes to life without the vision, support, and hard work of many individuals, and today I, on behalf of the Organizing Committee, take this moment to acknowledge them. First and foremost, I would like to extend my heartfelt gratitude to our chief guest, Dr. Ravi Kumar, Group Director, UR Rao Satellite Center, ISRO, for gracing the occasion. Thank you, sir. Your insights and inspiring words are added immense value to the theme of CISCON 2025 and have set a stimulating tone for the days ahead. I deeply grateful to our guest of honor, Dr. Shankar Venugopal, Vice President Mahindra & Mahindra. Thank you, sir, for sharing your valuable time with us today. Your presence reaffirms the importance of collaboration between academia, research, and industry. I sincerely thanks to Commander Dr. Anil Rana, thank you, sir, Director of MIT, for the inspiring address and the constant encouragements. I would like to express my deep gratitude to Dr. Shisha, sir, thank you, sir, the General Chair of CISCON, whose guidance and support have been instrumental in shaping the conference. I also thanks to Dr. Meenakshi Sundar, HOD of the department, thank you, sir, for his unwavering support. I thank IEEE Bangalore section for accepting our proposal and be a publishing partner of this conference. My deepest appreciation also goes to the convener, Dr. Chinmay. Thank you, sir. The co-convener, Dr. Nikita Goyal. Thank you, ma'am, for their dedication, meticulous planning, commitment that ensured the smooth organizing of this prestigious conference. To the session chairs and co-chairs, I extend my sincere appreciation for your willingness to lead the technical sessions and contribute your valuable time and expertise. Thank you, all the chairs and co-chairs. I thank all the presenters and participants of this conference, whether in person or online, who forms the backbone of this conference. Your contributions will undoubtedly lead to the meaningful discussions and knowledge sharing. I would also thank to all the reviewers for their valuable time and rigorous assessments of the submitted papers. Your detailed feedback has been essential in maintaining the academic quality of CISCON 2025. I also take this opportunity to acknowledge the tremendous support extended by MIT and MAHE administration, the audiovisual team, the finance section, website maintenance team, MIT security, and the staff of the MV Seminar Hall. Your behind-the-scenes effort have been crucial to the smooth execution of this event. I would also like to thank the Master of Ceremony, Dr. Cyril Zorov, sir, and all the members of CISCON 2025 Organizing Committee, along with the teaching and non-teaching staff of the Department, Instrumentation and Control Engineering, for your dedication and tireless efforts. Lastly, I thank each and every one of you, whether seated here or joining us virtually, for your kind presence and patient hearing. I wish you all a rewarding and enriching experience and CISCON 2025. Thank you so much.
Thank you, sir. Ladies and gentlemen, we have come to an end of the inaugural ceremony. On behalf of the Department of Instrumentation and Control Engineering, I take this opportunity to thank everyone present here. I request the convener to escort the dignitaries of the days. Tea is served outside the seminar hall. I request all of you to join for tea and assemble back in the hall by 10:45 for the keynote address. Thank you, one and all.
अभी 10:40 तक कुछ नहीं है, तब तक तो चलो बात समझते क्या है।
Mobility 2030, digitize, disrupt, democratize.
Friends, so what we are going to discuss now is coming down from space to ground. We're going to talk about mobility, actually, and mobility, what it will be like 5 years from now, the year 2030. Before I really get into my presentation, I want to hear from you. How do you think mobility could be different 5 years from now? What do you expect to happen? more autonomous vehicles, okay? More autonomous vehicles, even on Indian roads, is what you expect by 2030, right? Okay. At least Bangalore would definitely need more of those vehicles, if not yeah. What else? More autonomous, possibly, yes. What else do you expect to happen? How do you think these vehicles could be different from what we see today?
Use of more airspace.
More?
Airspace.
Airspace? Yeah. Yeah. Smaller crafts, maybe 2-seaters and 4-seaters.
No, I meant airspace in terms of air mobility.
Air mobility, but do you expect small carriers to fly around in between, like say Bangalore could be a small carrier, right? That's good. Absolutely.
Air buggy, air buggy.
Airways, waterways, possibly. I was in Goa a couple of months back. Waterways was very well utilized over there. Sure. So autonomous, and then airway, sure. What else? What else can be different? Vehicle will become intelligent, sure. And of course entertaining also, sure. Vehicle won't be passive. It's going to continuously interact with you. It's going to be intelligent and also quite entertaining, sure. Safety, absolutely. What do you think can happen on the safety front?
Maybe you can have more sensors to prevent accidents.
Sure, sure, absolutely. Safety would definitely go up, yes. Maybe pollution will come down significantly, and it will be a lot more fun being in one of those cars going forward. You will never get bored, that's true.
Easy parking or no?
Yeah?
Easy parking.
Easy parking.
Easy parking, absolutely. I have most of the damages to my car happen when I try to park in a very small space. I am really very paranoid about it. I know what it is like. So friends, that's precisely what we'll talk over the next few minutes. Mobility is what I want to focus on. We'll just spend a few minutes trying to visualize and trying to imagine how we can actually get this out working. And where do we need to focus when we want to innovate and come up with something really cool over there? Of course, mobility today is not that rosy. We do see a lot of pollution, especially if you're from a city like Delhi. You'd see there is a lot of tailpipe emission and there's a lot of concern around poor visibility during the winter months. Of course, we do see a lot of accidents happen on the highways and traffic jams. I've lived in Bangalore for many years. It's notorious for the traffic jams. Any time of the day, any part of the city, you have to really struggle to navigate through those dense traffics. It's not just Bangalore, many other cities that I go through have been having similar problems. And also, I'll briefly touch upon the manufacturing of these cars and also the way we repair and maintain them, how technology is coming in there and how things are changing. But a lot of very interesting developments, very interesting for us to see. But what I want to set as a primary context for the discussion over the next few minutes is this vision for mobility 2030, which is just centered around 4 zeros. Very easy for you to imagine how this is going to span out. Zero emission, that's for sure. How many of you believe that zero emission is possible over the next 5 years? A vehicle which doesn't emit anything from its tailpipe. Okay? How many of you? If you believe in this, just raise your hands. Okay? So, zero emission vehicle by the year 2030. Thanks for that. Zero accidents. Anybody like to raise your hands? Zero accident? Nobody? Nobody? Okay, thank you. Thank you. Thanks. Thanks a lot. Zero traffic jams. Even in Bangalore. Zero traffic jams. Okay? Zero waste. What I mean is zero carbon footprint, the way we manufacture these vehicles. Anybody believes that's possible? Zero waste? Okay, thanks. Aravinda. A lot of what we will discuss today is centered around a few technologies that we have been working on for the last few years: the electric vehicles, connected vehicles, autonomous vehicles, and also shared mobility. And what I added in the center as a blue logo is what I briefly touched upon during the inauguration, which is what's next in terms of software-defined vehicles. AI and algorithms and software really defining what the vehicle can do for you going forward. It's a very interesting ecosystem when we look at it, because it's not just about building an electric vehicle, it's about understanding the whole ecosystem around it, because we need batteries, we need motors, we need semiconductors, electronics, we need internet, we need communication protocols, needs to be cyber secure, a lot of very convergence of many different technologies that happens out here. And there are other things in and around it, which includes mining, processing of critical materials like lithium and cobalt that goes into the battery, the rare earths that goes into the magnets for the motors. These were things which are not there in a car even a few years back, and now suddenly there is a demand for all of this. And some of these we have and some of them we don't have, so we need to really start thinking about it. But one thing for sure is there are lots and lots of new technologies that are converging when you are talking about a car which is 5 years from now, the year 2030, whether it's materials or manufacturing or the way you energize these vehicles and the way you bring cognition, the AI and machine learning and analytics into the vehicle. All these are very exciting, and the vehicle that you will drive by the year 2030 will have all these technologies enabling it. So it's not that something in the lab, it's something that all of us are going to use going forward. And it's already happening, and you will see more of it over the next 5 years. What's also happening is a convergence of industries. The traditional automotive industry is now converging with the infrastructure industry, because you need charging infrastructure, you need good roads, you need smart signals for all this, for a seamless, hassle-free travel experience. Now, of course, the energy and power, because if all of us have electric vehicles, all of us go back home at 6 in the evening and connect our vehicle for charging, the grid is going to go crazy. We need something where the grid is smart enough to understand the demands and will be able to manage powering of so many electric vehicles out there. And of course, if you are going for an electric vehicle, it means you care for the environment, and naturally you don't want electricity that's generated by burning fossil fuels. You want clean electricity from solar or wind that's charging your electric vehicle. So all these things becomes a much bigger ecosystem out there. So that's a vision in terms of zero emission, zero accidents, zero traffic jam, and zero waste, right? Now let's try to imagine. This could be Manipal, okay? I had Bangalore in mind when I created these images, but this could very well be Manipal right here. There are these 4 images that we have, the one on the extreme left, then the top middle, the top right, and the bottom one, okay? This is how a city like Bangalore or Manipal could be by the year 2030. Let's have a raise of hands for the top left. Anybody for the top left image? Okay. The middle one? Do you have a lot of industries around here? Not many. This one, the golden yellow one. Okay. So I am right now in Chennai. In fact, we have a flyover which really looks like this. Okay. And how about this one? The bottom green one. Okay. Many of you seem to like it. That's good. That's some part of Bangalore actually. That's true. So these scenarios, I just given them more familiar names. I call them as Rajasa, Sattva, Tamasa, and Vinasha. 4 possible scenarios that can possibly happen over the next 5 years. Rajasa is all very dynamic. A lot of new technology is coming in, and everybody is readily adapting new technologies. So you see electric vehicles becoming better and better, software-defined vehicles, more and more AI and whatnot. That's a very dynamic scenario. Sattva is where we all decide that we will do what is good for the environment. Some of us start walking, some of us start cycling, some of us avoid flying. Yesterday I flew from Chennai to Mangalore. I wouldn't do that. So maybe I'll try to do this virtually so that I can avoid that much of carbon generation. All this is a Sattva scenario. Tamasa is what we have been doing all these years, that I'm not going to do anything. Somebody somewhere will solve the problem, because that's how it has happened in the past, so I need not really worry. It will happen. So that's a kind of a inertia thing, which we have been through for a very long time. Inertia, let's not even talk about it, because we really don't want to get into that scenario. I'm sure we as a community of engineers will be able to do something so that we don't land in that fourth scenario. But honestly, all four are equiprobable, depending on what problems we work on, depending on what ideas we pursue, we may end up in one of these scenarios. Very well. One thing, when we start trying to innovate and get towards creating this ideal mobility, which is zero emission, zero traffic jams, zero accidents, and zero waste. One thing that we need to really do as engineers is we have always been using our brain, the logical brain, to solve engineering problems and come up with great solutions. We should also start using somebody else who's also equally good when it comes to connecting with people, understanding the problems, the pain points, and defining the right problems. That's our more empathetic heart. The way we understand the problems of the customers, trying to put ourselves in their shoes and see what it is like for a person who is going through, for example, who is going through a Bangalore city traffic every day, twice a day rather, and what it is like to be somebody like that, and how we can put ourselves in that scenario and look at things from that perspective and solve the right problems. Or if you are looking at emissions, trying to look at what it is. For example, you see this poor traffic constable standing in a traffic junction, inhaling all those pollutants coming from all the vehicles all around. What it will be like to be somebody like that, who is going through all that day in and day out. It's very important for us to put ourselves in the position of people who are actually facing some of these problems, and then say, how can I solve those problems, and how can I make things better for them? So when you are in that position, you'll be able to better define the kind of engineering problems that you get to solve. It's very important for you to not just be a typical engineer, only using equations and numbers to solve problems, but also bring a lot of empathy into the way you look at problems. You understand what your customers like and they don't like, and then use your creativity in those directions. That becomes really, really important. So now comes a story for you, because you have been listening for a while now. So let's have a small break. And this is a story of a king from Kerala who was very fond of chess. So he used to have regular tournaments organized in his court. And one day a wise old man walks into the court and says, let's have a game of chess. And when the king asked what will be the reward like, what is the expectation? And the wise man says, I just need a few grains of rice. You see that the image over there. Just a single grain for the first square of the chessboard. And then 2, 4, 8, 16, 32, 64, 128, 256, 5,000, 1,024, 2,048, and so on. Just keep doubling, but it's only the grains of rice. It's not a lot. So the king does a quick math, thinks maybe it could be 100 bags of rice. Fine, let's go ahead and play the game. They play the game and the wise old man wins the game. Now the king has to give the promised reward. And that's when they realize that actually this number is pretty large. You just keep on doubling it, and you double it how many times? Across the board, squares of the chessboard, how many times you double? 64 times. When you double, you end up with this number, which is roughly 2,000 times the global production of rice actually. So although you start with a single grain of rice, you just keep doubling it a few times, you end up in this unimaginable number, which means even if you gather all the rice grown across the globe, you have to wait for 2,000 years to get enough to give the reward amount. Why this story is important? Because, friends, honestly, we are all very familiar with things that change linearly in an incremental fashion. The moment something changes exponentially, our brains just zap. We just cannot imagine what it is like. Just not possible. But that's a fact. The smartphones that all of you carry has a lot more computing power than the supercomputer center at the Indian Institute of Science where I went for my PhD. Even in early 90s, early 2000, the SERC, the supercomputing center, had less computing power than the phones that you all carry today. So that's possibly because of the Moore's law, where the computing power kept on doubling every 18 months. And the cost of computing also fell by half every 18 months. So that you can pack this kind of phenomenal computing power in such a small, compact device that all of us can afford. That's not just one technology which has been growing exponentially. When you talk about electric, connected, autonomous vehicles, we are talking about many such technologies which are growing exponentially. Some of them are doubling every 18 months. Some of them are doubling in 12 months and 6 months, much, much faster. And all these technologies are converging together in the vehicle that you all will be driving by the year 2030. Just look at this. Nothing is new. I'm sure you're all been studying many of these technologies. All I'm telling is all this will be there in the car that you will be driving 5 years from now. So what we need to change is, if the technology is growing so fast, the kind of problems that we decide to solve through our projects should also be exponential, not incremental. Instead of trying to say, I will improve the range of the vehicle by 10% or 20%, you should be talking about how do I double the range of the electric vehicle, or how do I improve the range by 10 times or 100 times even possibly. Because technology allows you to do that. It's only the limitation in our mind, because we have been used to an incremental world for many, many years. We continue to work and think in that mode. There are a lot of concerns around availability of some of the key materials like lithium, cobalt, that goes to the battery of the electric cars. So I started my own research a few years back around modeling this entire ecosystem. So Dr. Ravi Kumar talked about bringing systems engineering, a systems approach to problem solving. This is one way in which you can do that, where you talk about the whole world around EVs and batteries. If I start making more EVs, then I would need more batteries. If the battery companies start making more batteries, they will purchase more of lithium carbonate. And then the mining companies have to mine more of lithium. Naturally, because of the demand, the lithium price would go up. When the lithium price goes up, the battery price goes up. When the battery price goes up, the EV price goes up. Because almost 30 to 40% of the price of an electric vehicle comes from the battery. So how this whole system interacts with each other, suppose if government brings a new regulation that they will give some additional 20% discount when you go for electric vehicle, how that will change the whole scenario, whether it will lead to much faster adoption, or will there be a bottleneck, will things slow down? All these things can be modeled with the kind of computing power that we have today. And I built the first model about 5 years back. The last 5, 6 years almost now, we have been fine-tuning the model based on the kind of lithium prices, the battery prices that have been seen over the last 5 years. Now we have a very precise model that can exactly tell you what will be the price, what will be the demand for a variety of future scenarios. So today, AI, the machine learning and analytics help you to handle a lot of uncertainties, a variety of very complex scenarios, just through the amount of modeling and simulation that you can do in this space. So things become a lot more manageable today. One of the things that we are about 4,000 plus engineers at the Research Valley. One of the things that we have been training ourselves in to solve some of these complex problems and innovate is a method called TRIZ, which is a Russian phrase which translates to theory of inventive problem solving. All it does is looks for how similar problems have been solved in other domains, how I can get some ideas and triggers from those solutions and solve my problem much faster. A lot of this is available in the public domain. Whenever you people have the time, you can always look at it. I got introduced to it first during my PhD days, and subsequently I have got a lot of patentable ideas from this. Somebody mentioned during my introduction that I have some 30 plus patents. A lot of it actually had come from use of very systematic methods like this, which is something that I want you to keep an eye on. Because when you come to the industry, apart from your domain knowledge, what we also look for is how can you use your domain knowledge in a very creative way to solve problems and come up with innovative solutions that can be patented and commercialized. So knowledge of methods like this will be very useful to you guys. So there are few things that can really help you when you transition from university to industry, especially the current automotive industry. One is your design thinking, which is all about empathizing with the person for whom you are solving a problem, a person for whom you are building a product. Then the exponential thinking, let go of your incremental linear thinking mode and really start understanding that the technology is growing very fast and I should be able to target a 10 times improvement or a 100 times improvement rather than just a 2x or a 3x. I think that's a very conscious shift that we all have to make. The third is bringing the power of systems thinking, because with all your AI and software today, you can model very complex problems and get a much better grip on it than what you could do a few years back. But also, don't think you are the first to solve these problems. There are similar problems which have been solved by very smart people in many other domains. Methods like TRIZ makes all this available to you so that you'll be able to solve faster way and with lesser resources, fewer resources, you'll be able to do it. I think this is a very important shift that we all have to go through in order to really shape what is happening in the mobility space. I think the last few minutes, we just tried to visualize what mobility could be by the year 2030. And we talked about zero emission, zero traffic jams, zero accidents, and zero carbon footprint. And all these are possible, and we can achieve this over the next 5 years. When we do this, what will happen is you won't be just making the best cars for Indian markets, but we can take these cars to anywhere in the globe. For once in a life opportunity, we can be truly global leaders when it comes to electric mobility, which is the right direction towards sustainable mobility. So I'm truly excited to be working in this space at this during this particular phase when there are such big disruptions happening. And I'm sure many of you will also be able to contribute to shaping these technologies and make your own impact in shaping mobility for the future. And that's the reason why I thought I should come over here and share these thoughts with you. And any one of you who is interested in picking any problem relevant to electric mobility, I'll be very happy to support you, both at the individual level and also from an organizational perspective. Just look at these possibilities. How can your research, how can your ideas enable zero emission, zero accidents, zero maintenance, zero carbon footprint in the way we manufacture these vehicles, and finally the most complex problem, which is how do we achieve zero traffic jams even in cities like Bangalore. I think today's technology allows us to really set these ambitious goals and achieve this over a very short time, which is just 5 years. 5 years from now, I'm sure all of you will be having a brand new car and you'll be driving around, and that car will have all these features that you look at here. Thank you. Look forward to working with many of you all here.
Thank you, sir. We have one or two questions from the audience. If you have any questions, you may ask. Yeah, please.
So you mentioned a lot about like electric vehicles and sustainable driving, and so we know that you're trying to mobilize electricity into vehicles in the next 5 years, but you need a lot of lithium for that. Even though lithium is the solution forward, it's causing a lot of environmental problems while we are mining for lithium. Like in the states of Jammu and Kashmir, where lithium ore is found, there are a lot of people who are protesting because of the amount of casualties happening in the mining. So how can you make that sustainable, and how can you, sort of reduce the protest towards lithium mining and all of that? Thank you.
Sure. I think a lot of what we talked about will be achievable only when we mitigate some of the supply risks around these materials. Although you talked about lithium ore mine in Kashmir, it's going to take us quite a while to convert that into something that can go into a battery. Today, a lot of the lithium comes from only 3 countries primarily: Argentina, Bolivia, and Chile. That's it. So, even when you talk about batteries from China, the material comes from these 3 countries. And there is yet another material called cobalt, which also goes with the battery. That comes from only 1 country, which is Congo. That's it. Nowhere else. So with this kind of scenario, there are 2-3 things one need to do. One is to look at a different chemistry. So people have been researching on sodium instead of lithium based. So if you look at the periodic table, hydrogen, helium, lithium, beryllium. So when you look at this, it's in the order of you are looking for the smallest ion which can easily shuttle between the cathode and the anode. So you look for what is the next smallest that you can work with. That turns out to be sodium. So there is some research. It may take some time for it to go from lab to market, but that's one direction. The second is working around with the chemistry and modifying it through a series of innovation. Since cobalt was coming from only 1 country, so over the last 5 years, people have worked on cobalt-free compositions using manganese, nickel, so that there is literally almost no cobalt in the chemistry today. And the chemistry that all of us use across the globe today for electric vehicles is called LFP, which is lithium iron phosphate, which doesn't have many of these things, but lithium is still there. The other is also to look at recycling and reuse of these, so that you will be able to extract almost 90% of these critical materials from a used battery and make a brand new battery out of it. Okay. So that is called urban mining, where we make sure all the batteries are connected and they are processed to make new batteries. That's another. And there are 2 other very interesting frontiers. You should just be aware of it. It may take some time to catch up. One is mining the deep seas for the same minerals. Today we are talking about only mining on the land, but technology allows you to do deep sea mining also. And there are startups which are very aggressively pursuing that, and they are all well funded. So that's one dimension. The other is something very interesting called asteroid mining. Some of these asteroids are very rich in these elements that we are worried about. And that's again another place for you to look at. And asteroid mining is also possible today. We have technologies in place to do that. So these are very interesting frontiers. But one thing that I can tell you for sure is we need to shift from a constraint-based thinking to abundance-based thinking, where we say, okay, how can we use technology and innovation to make things available, to make things happen. I'm sure all of you can easily crack some of these age-old problems. It just needs a different mindset, but surely doable. Sure. But material is definitely a bottleneck. We need to address that going forward. Sure. Thanks.
Any more questions? Yeah, please.
Thank you. Yeah.
So good afternoon, sir. Like as you told, all this asteroid mining, deep sea, everything,
Yeah.
but we need to take into like cost as consideration. So for countries like India, electric vehicles should be like more of affordable.
Sure.
So considering. And I have like another question too, like when it comes to zero traffic jams. So only 2 OEMs, like when they are focused, it's not possible, I feel, because more of this depends on like governance, policymakers, because they need to develop the urban infrastructure.
You're right.
Yeah, even in Bangalore, like everything, the flyovers and the pending blue line metros. So if it comes, the traffic jam would have been like solved like 5 years earlier also.
True.
Yeah.
So it's a much larger ecosystem problem. For example, if you are in an EV, say you buy a Mahindra 9e and you are driving from Silk Board to Whitefield, you are stuck. It's not going to make any difference that you are in an electric vehicle. So this vehicle also has to be a connected vehicle, has to be a semi-autonomous vehicle, and possibly a shared vehicle. I'll tell you why. When you say connected vehicle, this vehicle can speak to the traffic signals and can speak to other vehicles all around so that they can coordinate the movement, the entire flow. When it's a semi-autonomous vehicle, primarily you are looking at a level 2 to level 3 kind of autonomy, that self-parking and lane deviation, all those basic features are there, so that there are no surprises, things just keep driving in a very predictable manner. Shared, because 4 people need not use 4 vehicles, the 4 people can get onto one vehicle and travel from Silk Road to Whitefield. Thereby there will be fewer vehicles on the road when you do this. So this kind of combination of things can definitely address, but what is important is a system level solution. When you talk about smart cities and smart mobility solutions, we need all this: electric, connected, autonomous, shared, all these aspects need to be there. In fact, I was in Dubai a couple of months back because we got an innovation award for our tar rocks, the tar. And there were 10 people from across the globe who were receiving the awards. The team which came after me onto the stage was the traffic police team from Bangalore. They won the award, a Global Innovation Award, for the attempts to really bring a lot of technology into this space. So people are trying a lot of things, and I'm sure we are not very far away from seeing very streamlined, very controllable flow of traffic even in Bangalore. I'm sure we are not too far away from that. The technology can take care of a lot of these problems that we face today. But for a country like India, we also talk about multimodal, where, for example, city movement can be battery electric vehicles. The long distance trucks and buses can be hydrogen or any other clean fuel. So, but for you to adapt public transportation, you also worry about last minute connectivity. You need something which can easily take you from the station or the bus stand back to home. All those comfort factors are there. So one need to look at it at a system level and solve, not just at a vehicle level. You need to think, sure. But thanks.
Thank you, sir, for taking us to the future of mobility and also inspiring us to incorporate design thinking, innovative thinking, and exponential thinking, systems thinking in our approaches to solutions, engineering solutions. I request Dr. Shisha C, Professor in the Department of IC, MIT Manipal, to present a memento to Dr. Shankar Venugopal as a token of gratitude.
Thank you, sir. Thank you. Thanks a lot.
Presentation has given a lot of scope for the students and participants to think about
very, very interesting problems we have got today. So maybe I'll come back and that we can sit with you all and the students to scope out some problems that they can work on.
The students' teams are working on electric vehicle, thermal cars,
sure.
solar vehicle.
Yeah. Let me spend more time and we'll figure out.
There are a lot of student projects. Right for this we can visit.
I agree. Thank you.
Thank you, sir. We will break for lunch and assemble back at various venues allotted to each session at 1:30. Thank you, one and all.